Question is, a medical company is running a REST API on a set of Amazon EC2 instances. The EC2 instances run in an auto-scaling group behind an application load balancer ALB. The ALB runs in three public subnets, and the EC2 instances run in three private subnets. The company has deployed an Amazon CloudFront distribution that has the ALB as the only origin. Which solution should a solution architect recommend to enhance the origin security? And the options are: Option A, store a random string in AWS Secrets Manager. Create an AWS Lambda an action for automatic secret rotation. Configure CloudFront to inject the random string as a custom HTTP header for the origin request. Create an AWS Wave ACL rule with a string match rule for the custom header. Associate the Wave ACL with the ALB. Option B. Create an AWS Wave ACL rule with an IP match condition of the CloudFront service IP addresses ranges. Associate the Wave ACL with the AL move the ALB into three private subnets. Option C. Store a random string in AWS Systems Manager parameter store. Configure parameter store automatic rotation for the string. Configure CloudFront to inject the random string as a custom HTTP header for the origin request. Inspect the value of the custom HTTP header and block accesses in the ALB. Option D. Configure AWS Shield Advanced. Create a security group policy to allow connections from CloudFront service IP addresses ranges. Add the policy to AWS Shield Advanced and attach the policy to the ALB. Correct answer is option D. Configure AWS Shield Advanced. Create a security group policy to allow connections from CloudFront service IP addresses ranges. Add the policy to AWS Shield Advanced and attach the policy to the ALB. Next question is, a company provides a centralized Amazon EC2 application hosted in a single shared VPC. The centralized application must be accessible from client applications running in the VPCs of other business units. The centralized application front end is configured with a network load balancer NLB for scalability. Up to 10 business units, VPCs will need to be connected to the shared VPC. Some of the business unit VPC CIDR blocks overlap with the shared VPC, and some overlap with each other. Network connectivity to the centralized application in the shared VPC should be allowed from authorized business unit VPCs only. Which network configuration should a solution architect use to provide connectivity from the client applications in the business unit VPCs to the centralized application in the shared VPC? And the options are: Option A. Create an AWS Transit Gateway. Attach the shared VPC and the authorized business unit VPCs to the Transit Gateway. Create a single Transit Gateway route table and associate it with all of the attached VPCs. Allow automatic propagation of routes from the attachments into the route table. Configure VPC routing tables to sending traffic to the Transit Gateway. Option B. Create a VPC endpoint service using the centralized application NLB and enable the option to require endpoint acceptance. Create a VPC endpoint in each of the business unit VPCs using the service name of the endpoint service. Accept authorized endpoint requests from the endpoint service console. Option C. Create a VPC peering connection from each business unit VPC to the shared VPC accept the VPC peering connections from the shared VPC console. Configure VPC routing tables to send traffic to the VPC peering connection. Option D. Configure a virtual private gateway for the shared VPC and create customer gateways for each of the authorized business units VPCs. Establish a site-to-site VPN connection from the business unit VPCs to the shared VPC. Configure VPC routing tables to send traffic to the VPN connection. Correct answer is option B. Create a VPC endpoint service using the centralized application NLB and enable the option to require endpoint acceptance. Create a VPC endpoint in each of the business unit VPCs using the service name of the endpoint service. Accept authorized endpoint requests from the endpoint service console.